All right, last class we took a look at how to find the partial derivative, basically the mechanics behind it. But what we didn't take a look at was what exactly is the partial derivative giving us? What is it telling us about the function? Well, we know to take a partial derivative, we hold one variable constant. Now, a way to think about that, this is the graph z equals x squared plus y squared. I'm going to hold the y constant. Now, of course, if y is a constant, that creates a plane, and it's represented by the blue plane on the screen right now. Now, the green axis down here is the y-axis. I can take this plane and move it to different y values. Now, depending on what y value is, whatever the constant is, that plane cuts the three-dimensional surface into a two-dimensional curve. So that's represented by this parabola shape up here. Now that parabola is the equation for the partial derivative with respect to x, right? The partial derivative with respect to x of x squared plus y squared is 2x. Now, as we put different values for x in, notice we're still finding the slope of the tangent line, just like we did in Calc 1. The only difference is, since y is being held constant, we're taking one slice out of a three-dimensional object, which gives us a two-dimensional object, and then we're finding the slope of the tangent line along that curve. So it doesn't matter how complicated the shapes look. Let's see if we can make something ugly here. What if I have sine of x plus y? And take a look at this mess. We still, here, if we're holding the y constant, we're still only looking at the slope of the tangent line as we move in the x direction. Notice that's just a sine curve that we're moving across. Doesn't matter which variable we hold as a constant, we can do it the other way. It just means the plane would be going, ooh, it's jerky. The plane would be going in the x direction, but we're still moving along that sine curve. All right, this particular demonstration is available on geogebra.org. You can see the website up here right now. Just go to the website, underneath material, type in my first name, Enoch, and you'll see several different demonstrations that might help you visualize a few of the more complicated shapes that we're going to use this semester.